Yeah, Dr. Ramaswamy sir, we can start.
Okay, okay, that's good. So very good afternoon, all my HVAC engineers. And how are you? All are okay? You had a nice weekend, relaxed? I hope you all had a good weekend because you need some energy to work again, to have a long week ahead of you. So I hope you had a nice weekend. So let me start my with the today's topic. But before I start, this is my habit. I just recollect whatever the things so far we have done and quickly, like a recapitule or whatever you call abstract. And then probably I will go to this one as a part of this advanced course in. So this is just for your information, actually. This is what normally we do in that. And then you also ensure that in your specification, don't give any ambiguity, even for the maintenance people, give the specification very clearly, even on the operation maintenance manual, because once you give the entire system, you are very happy, whatever you design, it has come now in on the install physically, but during the operation and the maintenance, during the life cycle of the equipment, if it is not being properly maintained, and whatever that design you have done will become futile. So this is an important part in that. So now, so far, we have completed almost last week 5 classes. Now today is my 6th class, and we will focus on that, designing a clean room. So a clean room is again another specialized topic in the same like hospital air conditioning, particularly for a design engineer, air conditioning engineer, is very important topic in that. What happened? Yes. So as I told you, air conditioning of designing comfort application has got so much easily you can do, because uh, it's not going to affect, even if the temperature you plus 22 plus or minus 2 degree, even if you have done some mistakes or even filtration, air quality, if you do some design mistakes also, that is not going to create any tangible side effect. But when you do process air conditioning, you have to be very, very careful. That is what I always tell. Process air conditioning design is slightly complicated and complex, and it needs special type of skills in that. I hope you all must have designed some of the clean rooms. Mainly the clean rooms are applied in mainly in pharmaceutical industries. Now, even due to this recent, for the last 1.5 years or 18 months, all these pharmaceutical industries got special attentions, and then a lot of manufacturing industries and many process industries, the clean room applications are there. So almost this is about the specialization of clean room is almost 50, 60 years old, or maybe 70 years old. And because this is again, most of the people who do the research, and they started this concept because if the environment, whatever the air conditioning is not maintained, probably they don't get to this one. This later stage, it has been extended to the manufacturing, then finally hospital, various things in that. That's what ASHRAE has got, federal standard has got one advanced specification. Then even ISO has also interfered, and they also have their own way of classifications on that. So as for first, I start with the ISO definition. What is a clean room? Suppose somebody asks you what is a clean room. Basically, it's a room or any area in which the concentration of the airborne particles is controlled. And because in any closed area, the air has to be treated properly. So when the airborne particles will be there. So that is to be controlled, and which is constructed and used in a manner to minimize the introduction, generation, again from the source, introduction, generation, and retention of the particles inside the room, and in which the other relevant parameters, example, temperature, humidity, and pressure are controlled or as necessary. So that room is called as a clean room. Now, if I ask you to define an air conditioning, a comfort air conditioning, basically it's a comfort air conditioning, one, control only temperature, humidity, and makes maximum air velocity and cleanliness. But here, more than that, particles, airborne particles. So that is how the specialty comes as a clean room in that. So basically, the clean rooms are designed to maintain extremely low levels of the particulates, such as dust,
Excuse me, sir.
airborne organism, vaporized particles. Yes, please, I'm hearing.
In the definition, you're talking about some vaporized particles.
Yes,
What exactly are they? Like
for
vaporized?
example, yeah, in the process industry, when you put some fumigation in that, some biosafety cabinet in the biological, the pharmaceutical industries, workstations will be there, work benches will be there. In that process, some vaporized particles will generate in the process, depending upon various process. Suppose if you are bearing manufacturing, in the bearing manufacturing clean room, like fiber optic cable process, which I told you long back in the 1990s when I was designing the fiber optic cable clean room area, process area. In that area, in that process, that will create many, suppose if you go to the laboratory, molecular biology laboratory or biological laboratory, there they may create a lot of skins, and that may be solid. Then, but in that process, you may have many equipments. As I told you, the hospital air conditioning, I put there will be a lot of humidifiers, spot humidifiers, steam humidifiers will be there. So these all try to create many type of vaporized particles in that. It may be that has to be controlled in that. So that is what the meaning in that. So typically, clean rooms have a cleanliness level quantified by the number of particles per cubic meter. So if I take one cubic meter volume of air, how much particle is allowed? That is how we normally define. If I say class 100, class 1, class 10, class 100, class 1000, class 10,000, then above it keeps on going. So the general meaning in the industrial standard, if I say class 100 means if I take 1 cubic meter of air volume at the volumetric rate, in that if I measure the airborne particles should not exceed more than 100 particles. The size of the particle is also defined, which is approximately less than some microns. Actually, you know what is a micron in that. That we will be going to see now in the subsequent discussion in that. So in my few slides will be related with the general characteristics, general features of the clean room, and then how the classifications, like we have ISO classification, then federal standard classifications in that. So as a role of HVAC engineer, what I have to do, what are the things I have to measure, how we can, because I know majority of items we have seen in indoor air quality. Filtration we have studied a lot. We have also studied about only thing now in the VAV system, probably tomorrow when we come, how the air distribution system. But generally, we discussed the air distribution, duct design, and everything during the earlier classes we have discussed. So I will not repeat all the things. Maybe wherever it is required, I will just recapitulate whatever it is required in that. So, and then finally, I will also some of the figures, how this clean room standards and what are the design aspect, what are the, as a HVAC engineers, what you have to do. And finally, how we can treat this types of clean room when we are designing. So what are the factors you have to consider? Then finally, I will conclude with the energy saving prospects in the clean room in that. This is what the entire presentation will be there. So as I told you, as a clean room is basically as definitely should have a pollutant should be very low. All it can be a dust, airborne microbes, aerosol particles, even chemical vapors. This was you correctly asked. In the process purpose, many people use different kind of equipment. So that equipment will definitely create many formaldehyde, many things in that. In the laboratory, you know that if you go to the laboratory, then they may be using so much chemicals. So they will definitely produce so much vapor in that. So that all has to be controlled in various stages in that. And then, so that is basically main importance of the clean room in that. That is how clean room air conditioning system is definitely different than the normal comfort air conditioning. Even I can put operation theaters and even ICUs is also one of the clean room, but they have a different class level in that. And we have already done a very detailed study about the different kinds of filtration, pre-filter, fine filter, HEPA filters, even alpha filters and all the things. And even we use some places ultraviolet to disinfect the air. And then the ultraviolet devices can be fitted to the ceiling light fixtures and irradiate air, killing potentially infectious particles because it's an industrial application. Some places As I told you earlier classes, some designers still they don't recommend to go for these UV devices because of the radiation effect in that. There is a different school of thought. But industry applications, for them, production is very important. And though safety is very important, but the most critical important is production. And they always take safety features on that. And on that basis, they will use in that many places in that. I hope some people must have designed a clean room. For me, I have done the clean room it was in 1992 or 93, those days. That what was everything was manual. It was a class 1000 clean room for the fiber optic this thing, but the process consultant was from Denmark. This is for the fiber optic cable manufacturing. I think this I explained to you on the first class itself as a design engineer, how I have convinced them actually, and the workstations also. It was a very complex design. But later stage for the pharmaceutical industries, I have not done much. But most of my hospitals, when I do operation theaters and ICUs, so I do special as a clean room only. It's basically sort of one of the clean room area only. And but pharmaceutical industries, definitely I have visited. I have seen many of the pharmaceutical industries. But if you ask me, personally, I have not designed for pharmaceutical industries or even manufacturing industries. Only one what I have designed was in 93, the fiber optic cables for a long time back. But now the standards have changed a lot in that from those days and now also. So the history of the clean room is, as I told you, this physics to Willis Whitfield. And basically, this is the Sandia National Laboratory, SNL. Last time also I mentioned to you about Oak Research National Laboratory. The same way, this Sandia National Laboratory is also, it is based on California. And this is one of the very reputed research institute, which normally they do a lot of biological-based, pharmaceutical-based research, biological micro research on that. So in that type of laboratory, they know a lot of control the microorganism, especially the airstream from the skin shedding, because they will a lot of animals they will take, they will store it, and then all this type of testing they have to do, even genetic lab, genetic engineering, all this will come under this type of specialized laboratories in that. So that time, this concept has started because they want to improve the quality of their research parameters. So probably the validity, to reduce the error aspect in that. So that is what this concept started. And then now it has become as a very specialized area in the part of air conditioning in that. So as such, having understood the definition and how it started the history, generally clean room, as I told you, though, the air has to pass through various filtration level, and ultimately you have a final levels or HEPA filters or alpha filters, and then all these classification, there are standards. Majority of the flow we normally maintain a unidirectional flow, laminar flow, which I have also shown some of the figures when I was discussing about the hospital air conditioning, how in the hospital air conditioning the filters are, the HEPA filters are kept at the, not at the terminal at the AHU level, but how we do the unidirectional flow. I've also shown some of the figures also in that. And in the ceiling, and then I also take the return or local put just above certain level height from the floor level, and then we extract the air actually. So that is how we are trying to create a laminar flow. I have also shown some of figure research papers, the difference between laminar flow in the adjacent area, how these particles, the airborne particles settles. And when you maintain this laminar flow, how it settles, that graph also is shown in one of my indoor air quality presentation in that. So, and similarly in the clean room, anybody even like, if anybody wants to go to operation theater, there are certain dress code. You cannot go like that. You have to go, you have to disinfect yourself, you have to change all your dress, special type of dress. This is all basically part of this clean room flow principle. That of course we don't have much, that is our administrative role. But as an air conditioning engineer, our role basically, when we start designing, the first aspect is as much as possible at the controlled environment from the outside. How we can stop this? That is the first point. Whenever you are your point you are going to consider. I'm going to design a clean room. What is the most critical point? I will always try as much as possible. I will minimize the introduction of the contaminants from the outside. Then the second one is the equipment, which we are going to use. Probably that may not be in your hand because that are the process consultant, process applications. So, but you also should get as much as information from them during your discussion. Majority of the time, they don't give the data properly. And I don't know whether I've shared you this experience. This was also probably 1989 or 90 or 91. I was in Nasi currency note press. And it was a printing press in that. You know, in the printing press, maintaining humidity is very, very important. Also, otherwise, being a paper is a gyroscopic material, nature, and you don't get the quality of the notes what print. We had a very tough time. I was not a design engineer that I have not designed that system, but I went there as a part of pre-testing and testing that time. So there we had a very special difficulties we faced because the equipment, what they bought later stage, because the whole process took almost 5 years. So there were a lot of changes in the equipment. What we did, probably the designer, what he designed 5 years ago was something different, but what installed was something different. So it was a very tough time. So that's what I'm telling in that the controlled environment must not generate or it should not give rise to the contaminants or any source of additional load in that. Third one is you also have to allow that you should not be allowed to accumulate. Even okay, there are limitations for everything. So for that, what you have to do, you have to have a proper airflow pattern. It may be laminar flow or a proper exhaust in that. Even if it is accumulated, on what basis we have to remove it. So what basis of protocols we have to maintain it. And last will be the as rapidly as possible, even if it is existing contaminant must be eliminated to the greatest extent possible in that. So these requirements are defined in the federal standard, and it takes an incredible amount of technology to achieve and maintain this objective there. So the HVAC system is a very specialized field of repairing through understanding of cleanliness. The guidelines also, as I told you, we have a federal standard, we have ISO standard also, and even all these various type of ASHRAE standards, 61.1 or 170 healthcare, even 90.1. Even we have ASHRAE standard 55 and all they talk about, but it's very specialized thing. If you want, basically you have to go for ISO clean room design manuals are available in that. Okay, so the specialty of equipment, controls, instrumentation, the building management system. These are the basic thing always as a design engineer you should keep in your mind in that. So what are the characteristics of the airborne particles? That you know that it always it may be airborne particles are solid suspended in the air. For our purpose, particles are defined as bodies because any solid particles have physical boundaries, and it may be ranging size that ranges from this much micron to this much micron. It can be liquid or solid particle material characteristics. So the size of contaminants and particles are described usually microns. So it's very fundamental. I don't want to, just for comparative purpose, those people who really are new to that, they should understand even human hair is about 75 to 100 microns in diameter. So a particle of, just imagine, a particle of 0.5 micron, it is almost 200 times smaller than the human hair. So can cause major disaster in the clean room. So this is what I'm just highlighting. Even your human hair is about 75 to 100 microns. But where now you are going to talk about the particle, which is 0.5 micron. 0.5 micron and a diameter particle of this one, even this can cause major disaster in a clean room also. In some of the subsequent discussions, I'm also going to talk about the efficiency. Majority of the time, the filters, they will always talk about 95% efficiency or 99% efficiency. Efficiency of the filters is not going to matter anything. How much is the size of the particles which is going to control? So that is that's what we specifically in our filter specification. In addition to the filter efficiency, we also very specifically specify the size of the dust particles in that. So that I have given only just to give an idea in that. So all the clean rooms, as I told you, we have different kind of classifications. So these classifications are based on the allowable number of particles per unit volume, as you know, per cubic feet or per cubic meter cube. And these all very clearly defined. Based on that only, the process also has been selected. Now, how a clean room area depends on the class number that is designated. We have designated, like for example, when you come to refrigeration, we have a refrigerant. How we have a refrigeration number? We have a certain ashtray as prescribed certain designation formula. Like if you see R11 or R12, so that we called as, it is basically a chemical formula is chlorofluorocarbon, dichlorofluorocarbon methane. These are the derivatives of the methane group, CH4. In that, two chlorine hydrogen atoms are replaced by chlorine atom. That's what the chemical formula is, CCl2F2, like that. So, but generally, a commercial man or a businessman or technician, for him, he understands it is R11, R12, R22. So the numbering system. So there is some technique they use. Same way here also in the clean room, they have also used certain kind of numbering system in that. So that is what the classification. This is a general one. I also compared it with the federal standard as well as ISO also. And we will discuss further in that. This is now available, and then how much less than this particle, how much is allowed permissible limit. You can see that less than 0.01 micrometer, and all these things are there in there. Now, when I mention a class 100 clean room, for example, it would not contain more than 100 particles bigger than 0.5 microns. If I take 1 cubic aware, this is what I told earlier also. Similarly, a class 10,000. Is it same? That's one. So then we have a different kind of typical in industrial use, class 1 and 10. Generally, we use production of laboratories or electronic integrated circuits, VLSI, even launching of rockets and all the things, parts preparation, part manufacturing, we use. Now, class 100, generally we use in production areas of photo labs, medical plants, operation theaters, sometimes class 1,000 also, depending upon the requirement. Then class 10,000, locals for the TV tubes and all the things. And class 100,000 is production of ball bearings. Then you have a class even 1 million, like that. So up to this one only. So this classification is for the cleanliness based on certain formula. It's like refrigerant nomenclature or refrigerant designation is also based on certain formula. So same way, this formula is also derived by international standard. And then on that basis, you can always classify that one. So these details are given on that. Now I'm trying to compare it now, the ISO as well as US federal standard. And I'm just comparing the standards are superseded by the publication of ISO specific, because ISO was published only in a later in the 2000 year, about 20 years ago. And before that, we have a federal standard. And so that probably you can approximately, when they call class 1, it is equivalent to ISO 3, and then ISO like that, these things are available, so that you can check it up. Whenever a client asks, you have to explain to the client, what type do you need a class 1, or do you need a class 10, do you need a class 100, or class 1,000, or 10,000, or 100,000, like that. So these all come under the standard actually there. So again, architecture is also another one important thing, because when you construct a clean room, it can be a starting from the workstation, from a small room, as good as a very big area. As my example, again, I'm telling the process industry, they have about 25,000 square meter area. More than that, I'm not able to remember. But in that, the process area where the clean room is to be maintained is only about 1,000 square meter or 2,000 square meter. And whereas as a HVAC man, we misunderstood. Then we started designing the whole area in a different condition. It involves so much capital cost and all these things. So later stage, when we discussed with the architectural and process consultant, it was clarified. This is just trying to explain you, the design is again a creative idea. It is not a single man job. It is a teamwork. It is an integrated part. Everybody. Again, all my lectures, I'm telling, from the day of the concept, from the concept stage onwards, every stakeholder should be involved, and there should not be any minimum amount of communication gap in the design. Yeah, most of the problems what we are facing now in the industry, it is basically because of the communication gap. And that is what many people, whether it's a manager level or a senior manager level, they always undergo various type of training, management, communications and all the thing. And in spite of that, a lot of improvement, not like in our olden days. Now so much improvements are there. You have so much sophisticated software to find out all these things in the project management execution. But at the same time, the attitude and the behavioral of the leadership also. As another example, I told you, we have used all type of sophisticated equipment. Even the company itself is one of the international reputed consultant we employed. But the buildings, it took almost a project delayed more than 4 years, and it involves huge amount of loss. The airport design, I'm talking in that. Sorry. So when it comes to HVAC system, mainly the pressure differential compared to the adjacent area. This also I have told you the positive pressure. Mainly all the operation that I also mentioned you positive pressure. Why this negative pressure has been included mostly in the laboratories, kitchen area, and all that. I have already explained also previous class in that. So generally, you should ensure that the supply airflow is in sufficient volume and cleanliness to support the cleanliness rating of the room. So you have to properly refer the standard, all this ASHRAE standard, whatever ASHRAE 170 or ventilation standard, and as per that you calculate it. You should ensure that it is a sufficient flow as per the class level also. And then you have to also identify, introduce a your duct design. You have to consider it in a manner to prevent the stagnant areas where the particles could accumulate in many places. Whatever you do, I am sure 100% nobody can eliminate it. But we can always try to minimize it by using improved design, improved format in that. So that whatever the latest available, probably we should use it. And we should always prevent this type of stagnant areas. Then as much as possible, use filtering from when you are taking outside air and or you are taking this recirculated air. Before that, you use all type of other filters so that the life of the HEPA filters will increase more, or alpha filters, so that you can take more, the life cycle will increase more. And because that other pre-filters and all the things probably will definitely help you to prevent all this type of thing in that. And makeup air, specified positive pressurization. This I told you, all clean rooms are at the positive pressure. So now whenever when you in the design stage, basically you have to understand about the movement of materials into the area, and then also at the same time about the people movement of, because people always carry so much infection because they are not staying permanently. Equipments are installed within the conditioned area, but people go out, they carry so much, and then how we have to disinfect them, or how they have to pass through various clean areas, various pre-clean areas, that like air curtain, air shower, and anti-room. So this all we have little bit discussed, but you will see in the end of this discussion, I am also showing some of the air curtains, air shower, and all the things in that. And then should be very clear procedures also should be maintained, but that may not be role of HVAC engineer. But if the end user who is going to use for which process, they should also in that. Similarly, we have to have a monitoring system. So all these pressure difference should be very properly monitored, preferably with the digital, because many times I've seen in all the operations that there is a differential manometers, but majority of the time it does not give the accurate reading. And then above all, these type of instruments also needs a proper calibration. And if you don't calibrate it properly, the error will always show the error many times, because every instrument needs a proper calibration, and the calibration also needs a certificate from the calibration authority. Every federal government, every place, they have even pressure gauges. I don't know how you people are recommending any pressure gauge at the site when they are installing in your chill water pipeline, or even your chiller, high pressure, low pressure, cutouts and all the things. So these pressure gauges, definitely time to time, it needs a proper calibration certificate in that. So as I told you, the clean room design, more than conventional temperature and humidity control. So how it is different from the normal HVAC conventional system? Definitely we have to supply more air changes per hour, because if you see normal comfort air conditioning, we take maybe 1.5, 2 or 3, a maximum 4 or 5. But here we have to air changes hours are very, very high. That means you have to have so much air. Then we also use high level of high efficiency filters in the clean room. In normal comfort air conditioning, we may not use this type of filters. Probably maximum we stop it with the pre-filter and then fine filters or like that. And similarly, room pressurization also. So this room is also positively pressurized all the time in that. So you need to ensure that your exhaust is definitely less than what you are supplying that. So these are some of the how it differs to that. Now, having said that, when it comes to filtration system, all the air entering into the clean room must be treated by one or more filters. Pre-filters, fine filters, and then final stages, high HEPA filters and alpha filters. These are some of the most common filters used in the clean room in that. And we also ensure that because every filter has got their own way of functioning. How much they remove, how much efficiency, and how various process like diffusion, dilution, various process, the filtration mechanism itself is a dynamics actually. Maybe I think probably Dr. Iyad has a very good explanation on that day when you attended his class in that. Again, as I told you, particularly these air filters, generally how the air filters are constructed. Now, if I ask you how the air handling units are constructed, we know that the body is constructed with a double skin. Normally you write the specification, then you have a cooling coil. Cooling coils are made with a header, and then you have copper tubes, sometimes even copper fins or aluminum fins. You normally different kinds of material based on even micro-channelized heat exchanger. Similarly, for the air filter, how you are going to, you have a major construction parts. Basically, you have filter media. The filter media can be what type of filter media you have to specify. As they specify all the things. Then what type of sealant, what type of frame, is it aluminum frame or it's a stainless steel frame, and even gasket, because when we are going to install this type of, what type of quality of gasket in that. So as I told you, media is the filtering material. A common type of media includes glass fiber, synthetic fiber, non-woven fiber, all these type of things in that. And sealant, you know, that is an adhesive. Frame is the one like a structure where it is going, the media is filter is inserted. So it can be made from various materials, including aluminum, as I told you, stainless steel, plastic, or wood. But it all depends upon your cost, your end user, or cost cutting, anything. Because as a first day itself, I can design one mechanism. I can same thing I can design for 100. Also depending upon your need analysis, need statement, and what type of quality we need in that. On that basis only, you can do that one. And similarly, gasket, face cord, all these type of things are various parts of the air filter. If I take only air filter as a detail in that. And so this I will also put in a graphical form in that how it looks like, how all this, like how the air flows actually, what is upstream side, what is the downstream side, just for the graphical representation, what I have shown earlier. And again, as I told you, how the filtration works is normally it works on the four process. One is impact actually. Various when the air impact touches on that. So because of that, what happens? How it is filtered? It is like when you are doing your, I don't know, whenever I work in kitchen, I always talk about the heat transfer, mass transfer. Even when I put my tea in my filtration, I see that how much particles are withheld and how the water fluid goes in there. So this happens many times, you know. As I told you, many times I always, maybe I may be exaggerating. A good designer is one. I'm not a cook. Honestly, I'm telling you that I'm not a good cook. I don't cook also. But majority of the time, many things in the cooking, every ingredients has to be applied at certain correct proportions. Though so much theoretical, we study so much standard, so much YouTube, we see that. But again, it comes by experience. Even one ingredient, if it is here and there, then the quality of the food definitely goes in that same way. Design is also like that. So it like in the filtration, it immediately first one is impact. So as soon as the jet of air, when it hits the filter media, it impacts, isn't it? And then second part is how it intercepts, and then diffusion. As I told you, probably you must have studied in heat and mass transfer diffusion principle in that. Then fourth one is electrostatic attraction. So mainly first three process, impact, interception, and diffusion applied mainly to the mechanical filters. And then electrostatic attraction is again another last one, influenced by the positive and negative charge one in there. So when you go slightly detail on that, when you talk about the impact, as I told you, the particle is traveling in the airstream, it deviates from the airstream to the particle inertia, isn't it? The moment it comes, something stops here and it collides with the fiber. And generally, the impact filters can only satisfactorily collect particles above 10 micron. So the bigger one all will be filtered. It will not be allowed inside. So 10 microns in size and therefore are used only as a free filters in multi-stage filtration. So this is impact for first part. The higher the velocity of the airstream, the greater is the energy imparted to the particles and greater is the effectiveness of the principle of the impact. Because the more the energy, the more this will hit, the more will come down. Now come to the from the name interception also, the large particles, because of its size, collides with the fiber in the filter that the airstream is passing through. In this method, the particles are small enough to follow the airstream. These particles comes in contact with the fibers and remain stuck to the fibers because of the weak molecular connection known as van der Waals force. This is a lesser diameter in that. So it's stick on that. Now, the diffusion. This is basically a Brownian movement. You must have seen in the physics. You must have studied the Brownian motion. Basically, it's a motion particle causes that particle to a contacted fiber works with a very small particle, even less than if it is a 10 micron. This may be 5 micron. This may come to the 2 micron or heap up even less than the 0.5 micron like that. So diffusion works with the very small particles and works in heap on alpha filters. The particles are so small that they move in a random motion, Brownian motion, causing the particles to acquire a vibration mode. So this is all physics behind that. I don't want to go more detail, but I just wanted to, because I know whenever I'm preparing my notes and all the things, as much as possible, I keep limited mathematics, limited derivations, because in when it comes to application engineering, practicing engineering, you need very limited mathematics. If I go start explaining Fourier series or complex numbers or differential calculus, academically it may be good, but when it comes to the practicing, probably as much as possible, I keep this as minimum as possible in that. So the smaller the particle, the stronger this effect. For a larger particle, over 1 micron in diameter, this filtration mechanism, definitely diffusion will not work. So this I'm trying to make you understand the fourth process. That is, the earlier one was, first one is impact, interception, and then diffusion. Then electrostatic attraction. This is the fourth mechanism. Plays a very minor role in the mechanical, because in mechanical filtration, this will not be there. So if a charged particle passes through an electrostatic field, because from the name itself, you can understand electrostatic, because you are trying to create charge in something. Electrostatic, because electrostatic forces, you know that, it is attracted to an oppositely charged body. Such charges can be generated and imparted to a particle in an airstream in much the same way as static charges developed during the pumping of one's air. Many of you, when you study in your physics, school physics, you must have learned about Gaussian surface, Gaussian's law, and the theorem. Maybe in the 11th physics or something that you can academically in that. So the typical electrostatic filter is made from the polyester, polypropylene, and these are some of the materials in that. So these are the 4 levels in that. So based on that only, the filter media rating is they have done actually. Commonly described and rated based on upon the collection efficiency, how much filtration, how much diameter, and then depending upon the efficiency, and then they also give the pressure drop, because we have to again select another machine called as blower or fan. I have to overcome all these pressure drop, whatever I'm calculating. I have to, because it's all mechanical ventilation. So I have to also select my fan or blowers, whatever it is in there. So actually, basically, dust efficiency of they normally term another one called as arrestance. This is another term actually. So the arrestance means a filter's ability to capture dust and describes how well in an air filter removes large particles such as dirt, all this type of thing. The dust holding capacity of the filter is the amount of by weight of standard dust that the filter will hold without exceeding the resistance of this much pressure drop. So this all there is a definition. So, and they also arrestance can be expressed by a simple formula. The details are given in that. So this is a filter media rating. On that basis, they calculated, and then they have also measured the filters by use called as a PSE, particle size efficiency. So the efficiency measures the ability of the filter to remove the particles from the airstream by measuring the concentration of the material upstream and downstream of the device. If the supplier of the filter only indicate, as this is what I was telling, if you say that the filter efficiency is 95 or 99, that does not mean anything unless it specifies the particle size. What size it covers? Is it 0.5 micron or 2 micron or 10 micron? That has to be specified. So the ASTRE standard quantifies the filtration efficiency in different particle size ranges and rates result as the minimum efficiency reporting value. So they call this MERV. This is already in earlier my indoor air quality class also. I have given the slide and I also explained to you. And then they have also different ratings starting from 1 and 16, because these are all organizations based on the research, and then they give this type of standards to us for practicing engineers. And how we use our wisdom. Yes.
These MERV values, do they generally measure these on a dry and clean filter or a wet and dirty filter?
Yeah, this is a testing method. And you have to ask for the
like, do they measure it on?
Yes, please. I'm just please tell me. Yes.
Do they measure it on dry and clean filter, this MERV value, or
Yes.
they can measure it on a dirty and wet filter?
There is, see, filter, they measure it. There is a filtration test also. There are 5-6 process. DOP test, wet mechanism, dry mechanism. It is there. It is there, which I'm coming now.
Okay, sure.
Yes, last slide I'm coming. How these filters are tested and how they are rated. How they are rated, it is coming in that. So normally, based on that is what the first class I remember. I told you have to specifically ask for the test certificate. If they are not test certificate, you like, for example, Camphil. I don't know what type of brand you are recommending for the filters. What type of filters normally you recommend in your design? What type of, normally you always have the standard manufacturer's recommendation. No? These type of filters will be there. Equivalent, like for example, when you're designing a chilling machine, you will write either the chilling machine will be carrier or train or yark or equivalent method. And you are not going to put carrier along with the frequency or local some system because of the quality, because of the some standard, isn't it? Same way, when you are writing the filters, we call this material approvals, MOS. This is what in the first class also I told you how much you people go and you inspect at the factory. Many of the times you have to go and inspect at the factory. And factory installation inspection certificate also a part of your site measure, and that is a part of your invoice. In that majority of the contract, the cost is hidden in that. The cost is given actually, and that depends upon the scale of your project. Small. I don't expect that if I have a 10 split ACs, we know all the things. But if I am going for a super specialty hospital where the controls are very stringent measures are there, I know the chillers are maybe each chiller is costing 1,000 ton, and I have to also see the performance of the factory. And at the various, because they have if you visit any factory, there will be a testing area will be there. Test measures will be there. Controlled environment, then they have quality control. Though the factory issues the test certificate, but still based on that, it all depends upon your as a designer, as a consultant. You can always waive the inspection, or if you can insist that to go to the factory and inspect it. It all depends upon your jurisdiction. Because as a design engineer, major capital equipments, I prefer to go and I stand there, I witness it. 1 day, 2 days, some of the equipment I have to witness even 2 days, 3 days. This all depends upon that. So this also I'm going to come in the subsequent slides, the various type of test, DOP test, wet dry test, and all the things I'm coming in that. Similarly, when it comes to the HEPA filters, diffusion principle, as I explained to you, And this is also the final stage where it removes particles very as small as possible in that. And this you always glass fiber media in the thickness of the have pressure drop of this much, high pressure drop will be there. And HEPA filters are not MER rated as they exceed the acid test protocol used in this. Is what I'm telling you, that we have different kind of test protocol as Ashley is telling in that. We have a test, some of the tests I'm going to explain in the subsequent slides in that. So HEPA filters does not come under the MER rating in that. In fact, HEPA air filters are the only mechanical air filters that are tested and certified to meet a specific efficiency at a specific particle size. All HEPA air filters must meet a minimum efficiency of 99.97% at 0.3 microns in that. And now come to this alpha filters. It still stands for more ultra from the name itself. Ultra low particle air, growing a market demand from advanced science. And you have a nanotechnology nowadays. Manufacturing technology is also improving. And so all this, it gives 99.999 efficiency. You know, even it allows this 0.0 only 0.001% of maximum penetration in that. So, but again, it involves money. It involves money. It depends upon your process. Some process we need this type of so much cleanliness level, but honestly, I have not designed that type of thing. Maybe this type of cleanliness, clean room may be required. Majority of the things on research applications or military applications, because where they need a very, very stringent control. Not even a small thing will they can tolerate in that. So that type of thing only they use in that. But generally, normal air conditioning, we have maximum up to HEPA filters in that. And that's the test information, for example, the efficiency of 99.9 and 99.9% for HEPA filters look similar, but in reality, the difference is not insignificant. You see, a 99.9 solution is efficient filter as a fractional penetration of still we have this much, isn't it? While 99.9 filter is fractional penetration this much. You see that? Still you are allowing this much penetration inside. So this means that a 99.99 filter is 3 times more efficient in removing 0.3 micron particles. So just for understanding only, I know mathematical terms you understand, but still I thought that I should highlight it in that. This is what I'm coming in that, filter testing in that. So as I told you, the efficiency of the filter is paramount important, very important, and it has to be measured in an appropriate way. Typically, the filters are shop tested and only provide the quality certification for required efficiency to the end user. You should insist for the test certificates. Majority of the time, people in the market, people don't bother. They don't even ask for that, or even you don't specify in your specification. If you don't specify, the contractors will always take undue advantage of that one, and then they will go for any type, because manufacturing of filters is not big rocket technology. So the people can do that one. But you want to maintain the quality, you want to maintain the standard, then you have to go for a test certificate in that. So this for a check of the filter seal is recommended on a 90-day basis. The complete scan of the filter 2 times a year. There are 5 fundamentally different methods used to evaluate efficiency. One is the PCM, particle count method, the weight method, the atmospheric dust spot efficiency method, and then the cold DOP method and the hot DOP method. So these are the various methods for the filter testing. Let us see quickly one by one. Theoretical count, probably you will understand, most of you may be knowing actually, or if you have visited any of the filter factories. I have visited 1 or 2 factories actually. I know that is how I know I can visualize that one, and how they manufacture it actually there. And the particle count method, actual particle count per unit volume of air is determined through a microscopic analysis of the air sample. They normally take the air sample and then do the under the microscopic they put, and then this procedure is definitely very tedious and susceptible to human error, because how you look on all the things. So the dust concentration must be quite low. If the dust concentration is too, this sampling cannot be allowed to become too dense to count it. That's very difficult. So this is what simple. The name itself, the particle count method. So this we can use it for some applications of filters, pre-filters or something like that. When it comes to the weight method, what did it indicate? the weight of the dust removed by the filter as a percentage of the weight of the dust in the air before filtering. The weight arrested test is a simple test which involves feeding a synthetic dust. You artificially generate a dust and to a filter and rationing the weight of the dust exceeding the filter to the weight of the dust originally fed into the filter. Simple. You allow this, how much measure it other side and this side. So this method is also very popular and easy to use because, however, it has some shortcomings because weight measurement is given predominantly the weight of the largest particles in the sample. Since small particles have little mass, this method offers almost no way of factoring a small particle collection efficiency. How? Because, like for example, I want to measure now a weight of 0.5 micron. So the weighing mechanism is also very difficult. You go to the goldsmith. He used a different kind of weighing scale, isn't it? Though we call nowadays all digitalization, everything has come. But to up to which level, least count way or go, so that depends upon the weighing machine what we are using in that. So that is the reason we have also limitation, but we can use it for some purpose in that. Then another one is the atmospheric dust spot efficiency method. So in this method, the small particle is very critical. The dust spot test. The dust spot test is generally be used. The atmospheric dust spot. So the ambient air is passed through a test filter, and the air stream has a special test filter in front of it. So there is a test filter. Then we have also a special filter in front of it, and behind the test filter to monitor the presence of these air particles. In time, both filters become soiled and are measured optically by using optical parameters for relative soiling. So these results are then translated into a filter efficiency rating. So there is a standard manual on that. So you completely convert into that one. So the justification of for using such a test is that it is based on one of the absorbable effects of the air pollution of the soiling effect. How this air, since even micros level, how it soil the on that this soiling effect in that. So what is the drawback of this one? It uses atmospheric air because the air changes constantly. It is difficult to obtain a repeatability for verification. So as a result, many tests have to be run and the data have to be averaged. It is not 1 day, 2 days. So all these data is average, and then you have to go for a mean, the regression, or the regression analysis and all the thing. Now come to the DOP test. That is DOP means dioctyl patholite test actually. And that is for all these things. It can be used basically the dioctyl patholite test generators produce aerosol at room temperature. They produce aerosol with the particles ranging in size from 0.2 to 1.2 microns and within a mean diameter of 0.7 micron, average actually. The aerosol is introduced in the units where you want to test it in that, being tested, and the light scattering due to the particle concentration, scattering is measured at the inlet and outlet of the units, where entering and then outlet. Because the light, then you are also passing through the light scattering varies in direct proportion to the particle concentration. The collecting efficiency of the unit can be expressed as a function of the difference in light scattering measured at the inlet and outlet at any given time. So this is for the cold TOP test, but for this, there's so much mathematics involved. All this study testing and all the things, I have completely removed this mathematical explanation. But if you go to the factory, you have to also insist. Generally, for heat bubble test, we generally recommend this cold DOP test or hot DOP test in there. This is nothing but hot means DOP is evaporated by the heat and condensed to form of 0.3 micron particles with a very little variation in size. So this particle size is most difficult for all kinds of air cleaners to collect that will normally produce a slightly lower efficiency on all kinds of air cleaning devices than the cold DOP method in that. So as I told you, heat bubble tests are tested using hot DOP method, and so here DOP is boiled, boiled, and the vapor injected into the air stream. As the vapor condenses back to an ambient temperature, it forms very uniform droplets of this much by use of light scattering instrumentation. That physics of that light scattering instrumentation, which I'm skipping actually. Most of that I'm assuming you know. Otherwise, you have to refer some of the things because there's so much mathematics involved on that. The upstream and downstream particle concentration can be measured. So in essence, what is the summary? If 10,000 3.3 microns and particles are blown into HEPA filter, air filter, only 3 particles are allowed to pass. So thus you get 99.97 at 0.3 micron rating. If you were to use HEPA filter test at 95% efficiency, as a air filter, they would be about 50% of efficient on 0.3 micron size particles once they loaded up with the dust. So HEPA air filters are at least 50% more effective at removing the respirable sized airborne particles than any of the air filters on the market in that. So that's what we always insist for the ASHRAE test certification. ASHRAE test certification is a must. And then after that, we also go for the field testing that the federal standard defines. Testing of this absolute filter, HEPA filters, the scan testing, laser testing. So sometimes it is not possible to use a DOP test with a particular counter because of the concentration of the aerosol is so high that the counter becomes saturated at jabs because you have to create a hot spot in that. So requiring to the factory for repairs. So for that purpose, only this type of tests are recommended at the in case if you are not doing the field testing that. So standard testing absolute filters use photometers and DOP techniques to measure the efficiency and scan for the pinhole leaks. Similarly, laser testing, laser beamed electronic particles spectrometers are also capable of counting the particles in very small size. So this is all we will leave it to the manufacturers of the filters. As I know, standard manufacturers they always follow the standard quality material like Camphil. These are some of the standard manufacturers for their filters. For them, the filter is their family, their business. So normally they compromise with they don't compromise with the quality. They follow all these professional standards in that. Okay, and then come to the installation during the design. How this type of filters have to be installed. That is a general truth. You know that HEPA and alpha filters has to be installed always in the ceiling, actually. Directly on the ceiling in the clean room is driven by the desire. What is the desire? To minimize the dust collecting surfaces, such as the inside of the duct work between the downstream of the face of the filter. So remote mounting of filter is also common nowadays. We all, like for example, as I told you, the operation theater. HEPA filters, ideally, I want to locate HEPA filters inside the operation theater, where the operation table is there above that. But practically, it is not advisable because patients are there every time people go. The HEPA filters also needs, and though I provide so much type of free filters and fine filters, but HEPA filters also needs proper modification. Pressure, though the pressure difference, it has to be removed. So how has to go? A technician has to go. Somebody has to go there, have to remove it. So for that purpose only, we always put in the remote. So the AHU will be maybe 100 meters or 200 meters, 500 meters, and then the filters are there. So that is what, again, when the carrying the ducting, probably it may again carry the risk is there, the risk management. So this all depending upon what type of system you are designing. That is the reason I always insist. Architect you have to always be very clear. You have to explain to the architect, look, my operation theater is here, and I have this much limitation of this length. So you don't give me my plant room, which is another, say, 500 or 1,000 meters far away. And if I put this HEPA filters, I have to the HEPA filters locally at the local hood in that. Or you have to give some local shaft where I can keep it there. Then when you provide the local hood, there should be a access also to go there. So these all come in that. Some of the things are highlighted in this type of standard in that. So the average filters properly installed with the frequent changes of the filter should last from 5 to 6 for life cycle in that. So there are some filters probably like if you are exposed to the hazardous particles like laboratory and all the things, pathogenic organism, it of course we have to change very frequently. Even the hospital normally, the infection affected patient, when we have a HEPA filters, when the infection patient is removed, we normally even don't touch it. We remove we go with the complete truss with the mask, all this type of PPE, and then we remove it, and then we incinerate it. Actually, we send it to the incineration, medical waste, as classified as a medical waste in that. Okay. Similarly, we have also box type filters and flange type filters in the selection that in the catalog will be available. So it is all depending upon your wisdom. You have to select it in that. Okay. Now we have to talk about the phase velocity. And so can we have 5 minutes break now?
Sure, sir.
Okay. So just if you are ready, just call me. Then I'll take some water.
Hello. Hello, Dr. Ramasamy.
Yes. Can we start?
Sure, sir.
Yeah. Okay. Thank you. Just my first part, I was talking what is a clean room definition and ISO as well as federal standard, and then various classes. And then as a HVAC design engineer, mainly the main parts is basically how we have to basically from the source, the air velocity, air distribution, filtration, basically from the source, how we have to eliminate. So that's what we focus more on the filters, how with the filters, basically the various kinds, how the filters are being tested. And now come to the velocity. In this second part, I'll be focusing on the what type of velocity normally we have to consider, because it all depends upon my air handling unit. Then we will also see a little bit about the air handling units, and then how we take the return air. Some places we have to take the 100% fresh air, and that and then we also will talk about the various different kinds, like workstation, smaller one, bigger one, clean rooms. And then finally, we also talk about this air shower, where air shower, and then we have also airlock rooms, because since we maintain different kind of pressures actually in the clean room areas. So, and then the final conclusion will be the architecturally, what type of material that may not be relevant to you as that, but still you can always see if the architectural recommending some different kind of materials. You can always, this all I have collected from the standards, this type of standards, what they are telling, that's what I compiled it in that. Okay. So now, the second part, the phase velocity, like particularly for the ceiling mounted filters, it can go, the range is given 130 foot per minute to 50 foot per minute in that, on the design of the system actually. So on that basis only, you have to also work out your calculations, work out the bill of materials in that. Similarly, normally you have a cabinet fan or air handlers with the HEPA filters racks on the discharge side. So these type of small applications we use in the hospital generally, because inside the hospital, when they do this type of construction work, they create so much dust actually. So for that, we always use the portable type of HEPA filters unit. And then there the high speed will be there, and the velocity is also higher. But that comes as a product. That does not come as a system in that. So that type of products also may be available in that. And then free filters, you have to provide as much as correct filters to extend the life of the HEPA filters. Is what, to prolong the life service of the HEPA filters, you have to provide the free, definitely free filters we have to provide everywhere. Because if you have free filters, no